All right, let's dive in. Today, we're going to become what I like to call a model doctor. Think about it. Our job is to check the health of our AI models while they're training. And just like any doctor, we need the right diagnostic tools. For us, that tool is the learning curve.
So you've done all the hard work. You've prepped your data, you've built your model architecture, and you finally hit train. You see all these numbers scrolling by on the screen, but what's really going on under the hood? Is your model actually learning? Or is it just, memorizing the answers to the test? Is it struggling? This is the stuff we absolutely have to know.
So here's our game plan for this checkup. First, we'll learn how to check the model's vitals. Then, we'll figure out what a healthy model even looks like, our baseline. After that, we'll get into diagnosing the most common problems you're going to see. Then, we'll talk about the right treatments. And finally, we'll wrap it all up so you can master these skills yourself.
Okay, first things first. Every good doctor needs their toolkit. And for us, our most important, most fundamental tool is going to be the learning curve. This is our window, our MRI machine, into the entire training process.
So what exactly is a learning curve? It's really simple. It's just a chart that shows you how well your model is doing as it trains over time. I mean, think of it literally like a patient's chart in a hospital, tracking their temperature or blood pressure to see if they're getting better. That's all it is. Now we're going to focus on two main vital signs. On one hand, you've got loss. This is basically your model's error rate. It's the bad stuff. We want to see this number get as low as possible. And on the other hand, you've got accuracy. This is the good stuff, the percentage of things it gets right. And of course, we want to see this go up. These two lines together tell a powerful story. All right, we've got our charts, but a chart is pretty useless if you don't know what you're looking for, right? So before we can start spotting sicknesses, we need to know what a healthy, successful training session looks like. This is our baseline, our picture of perfect health.
A healthy model has a few really clear signs. First, you'll see the loss, the error, go down in a nice, smooth, steady curve. That's a great sign. Second, you want to see that the performance on your training data and your validation data are pretty close together. A huge gap is a red flag. And finally, eventually, the curves will start to flatten out. That's called convergence, and it's basically your model telling you, okay, I think I've learned about all I can from this data.
Now you might be looking at your own curves and notice something kind of weird. The loss curve might be pretty smooth, but the accuracy curve, it often looks all jagged and steppy. It goes flat for a while, then suddenly jumps up. So what's going on there? This is a super common question, and thankfully it has a pretty simple answer.
Let's break it down. Imagine your model is trying to decide if a picture is a dog. Let's say a dog is a value of 1. The model predicts 0.3. Well, that's wrong. As it trains, it gets a little better and predicts 0.4. Now, its loss has improved because 0.4 is closer to 1. But when you round it, it's still 0, so the classification is still not a dog. The accuracy stays flat. It's only when the prediction finally crosses that 0.5 threshold that the answer flips to dog, and boom, you get that sudden jump in accuracy. That's what creates those steps.
Okay, perfect. Now that we know what healthy looks like, we can get to the really fun part, diagnosing the problems. This is where you really start to feel like a model doctor, spotting the telltale symptoms of common issues right there in the curves.
And patient number 1, the most common ailment you will ever see, is overfitting. This is the classic case of a model that basically memorizes the training data. It's like a student who aces all the homework questions but then completely bombs the final exam because they can't handle any new questions they haven't seen before.
The key symptom of overfitting is that big, diverging gap. You'll look at your chart and the training loss is just plummeting, going down, down, down. Looks great, right? But then you look at your validation loss, the model's performance on new data, and whoa, it's starting to plateau or even creep back up. That growing space between the two curves is your giant, flashing red light. That's overfitting.
So what's the prescription? Well, you've got a few go-to treatments in your medical bag. You could add regularization, like dropout, which helps prevent the model from relying too much on any one part of the data. A really popular one is early stopping. You just stop the training right when you see that validation loss start to tick up. Or you can try feeding it more diverse data, or even just make your model a little simpler.
Next up, we have the total opposite problem. Underfitting. If overfitting is the student who only memorizes, underfitting is the student who is just not getting the material at all. The model is too simple or hasn't had enough time to learn even the basic patterns in the data.
The symptoms here are kinda sad, to be honest. The curves just look flat. Both your training and validation loss stay really high, and they plateau almost immediately. Your accuracy is terrible, and it's not getting any better. The model is basically screaming at you, I'm not smart enough for this problem.
So the treatment here is usually to give your model either a bigger brain or more study time. You can try using a larger, more complex model. You can just let it train for more epochs, more time. Sometimes adjusting the learning rate helps. And, it's always a good idea to just double-check that your data itself is clean and pre-processed correctly.
And our final patient is the one with erratic, unstable learning curves. You'll know this one when you see it. The training process isn't smooth at all. It's chaotic. The curves look like a seismograph during an earthquake. They're just all over the place.
Yep, you'll spot this immediately. The loss and accuracy curves will be super noisy with these sharp spikes and deep drops. There's no clear, steady trend of improvement. This is almost always a sign that your learning rate is too high. The model is trying to learn, but it's taking such giant leaps that it keeps overshooting the best answer, again and again.
To calm this patient down, the first thing you should always try is just lowering the learning rate. Tell it to take smaller, more careful steps. Another great move is to increase your batch size, which helps create more stable, less noisy updates. Both of these will help smooth things out and get you back on a healthy learning path.
Okay, I know that was a lot to take in at once. So let's pull all of that knowledge together into one simple, handy reference guide. Think of this as the diagnostic cheat sheet you can pin up on your wall for your next project.
Here it is. It's really this simple. If you see your validation loss going up while your training loss goes down, that's overfitting. Your first move should be early stopping or regularization. If both your curves are high and flat, that's underfitting. You probably need a bigger model or more training time. And if it's all just a noisy, spiky mess, that's erratic learning. Your best bet is to lower that learning rate. It's your quick 3-step diagnostic right here.
We've covered the basics of how to diagnose your model's health. So now, let's just wrap up with the core principles, the key takeaways you need to really master this skill and become a great model doctor.
Let's just boil it all down. First, your learning curves are your best friend. Always, always look at them. Second, know the 2 big red flags. That diverging gap means overfitting. Those sad, flat curves mean underfitting. Third, have powerful treatments like early stopping ready to go. But you know what? The most important thing is this. You get good at this by doing it. Reading the signs becomes second nature with practice. You just have to train models and watch what happens.
So the next time you hit that train button, don't just minimize the window and walk away. Pull up those learning curves, look at them closely, and ask yourself this one simple question. What are my model's vitals telling me? Because now you actually know how to read the answer.